All right. Hey, class. We are going to be checking out notes for section 1.3 today. We're going to be solving equations with variables on both sides of the equal sign. When we are working on these types of problems, the name of the section really kind of gives away what's different from what we've been doing the last couple days with solving equations. So again, quick friendly reminder, what is necessary in my answer when I'm solving equations? That's right, my answer needs to have an x equals in it. And basically when we are doing this, we're trying to undo everything around the x. So we started off with our initial one-step equations where if I had something like x divided by 5 equals -2, I would ask myself, what is my variable? The variable is x. What am I doing to x? Dividing by 5. How do I undo divide by 5? Multiply by 5. And so when we are doing the multiply, I love it when we put parentheses around both sides of the equation, and then we write the number in the top, whatever we're multiplying by. And then we do that to show that our fives are going to cancel top and bottom here. And we're left with x equals, and then we're going to do -2 times 5, which is -10. Well, then we started getting into problems that looked a little bit different in that they had two operations happening to x. So what if I had like a 1/2 x plus 7 equals 3? And so now I see a multiply by a half, but I also see an add 7 happening on the same side of the equal sign with the x. So when we do this, we undo the number first, the one that does not have the variable. So we're going to undo +7 by subtracting 7 from both sides. Then once we undo the add or subtract, then we undo the multiply or divide. And I taught you guys in class that when we have a fraction in front, we can either take both sides and divide by that, because I'm taking x times 1/2. So I undo that by dividing by 1/2. That's one way. Or because it's a fraction, I can also multiply by the reciprocal on both sides. And so either way is fine. So we're going to have x equals -4 times 2 is -8. And that's my answer. The problems for today are going to look a little bit different because now I'm going to have something like this where I have 5x equals 24 minus 3x. This time, not only do we have two copies of my variable, but they're on opposite sides of the equal sign. And so what we have to do first is move one of them over to the other side. We need to group the x's. That's kind of like our first step here is group the variables. We need to get them on the same side of the equal sign. And so what I usually do when I look at this is I say, okay, here's my whole number. Let's get it so the whole number is on one side all by itself, and then the variable is on the other side all by itself. So I'm going to take this -3x, and I want to put it over on the other side of the equal sign. But in order to do that, in order to move things from one side of the equal sign to the other, I need to add it or subtract it. Now, this gets confusing because I was telling you before that if I want to undo this, I need to divide to undo that multiply by -3. But this time I'm not thinking undo here, okay? When we're grouping our variables, I need to think move. And when I move it from one side to the other side of the equal sign, I'm basically, since I'm subtracting 3x here, I need to add the 3x to the other side. Okay, that's what moves it over here. And then we can combine our like terms. So we've got 5x's and 3x's. So the x's stay the same. 5 plus 3 is 8. And then I've got a 24 left on the right-hand side of the equation. And now I undo just like normal. I'm gonna recognize that I'm taking 8 times x. So I undo that, multiply by 8 by dividing by 8, and x equals 3. Okay, let's do another one. Let's do x plus 3 equals negative 4x. Now, quick notice here. If I think to myself, subtract 3 to move it to this side of the equal sign, I haven't gotten my x's together. Okay. I've not broken any rules. I've not done anything wrong, but it's not been a helpful move just yet. Okay. So when I'm looking at my original problem, I like to look for, again, where is my whole number? And so I want to get it by itself also. I want to get numbers on one side of the equal sign, and I want the variables on the other side of the equal sign. So I want to actually take this x and move it over here. And because I'm moving it to the other side of the equal sign, I'm going to, this is a positive x because it doesn't have a number in front of it. And so I move it by subtracting it to the other side. Then I get left with just my 3 equals negative 4x minus x. First of all, what did we say was the coefficient in front of a variable if I don't see a number? It's a 1. So I'm really doing negative 4 minus 1, and I get negative 5, and then the x. A lot of people will accidentally see negative 4x minus x, and they'll just think that the x's cancel each other out and just give me negative 4. And that is wrong. Okay, don't do that. This is wrong. So what we need to do is we have to remember that a number in front of a variable, if I don't see it, that number is 1. The coefficient is 1. And so then we combine the coefficients. Next, we will get x by itself. So come over here and figure out, do I need to add 5? Nope, not this time. Because this time I'm taking negative 5 times x. So I have to undo the multiply, and I do that by dividing. X equals 3 over negative 5. You can leave it as a fraction. You can change it to a decimal. And so I'm okay with x equals negative 0.6. That's fine as well. That's it. Now, what if I have one like this? I'm going to throw in some parentheses in here. What if we do 3 times 3x minus 4 equals 1/4 times 32x plus 56. Again, I've got variables on both sides of the equation, so I'm noticing that. But I also notice that right now I have these parentheses. And how do we undo the parentheses again? That's right, we distribute the number in front. So we're going to distribute, distribute. This one will distribute and distribute as well. So both sides we distribute. 3 times 3 is 9. And then the x comes along. 3 times -4 is -12. 1/4 times 32 is what? That's right. It's 8. So it's 8x. And 1/4 times 56 is 14. Now, in this case, we have variables on both sides and numbers on both sides. So it does not matter which direction you go. If you want to subtract the 9x over, that is just fine. Go for it. And we're going to do it this way because I want to point something out. But if you wanted to subtract the 8x over to the other side, that would be fine as well. Once you do your first step, it kind of points you along the path of what to do for your next steps. So my 9x and -9x cancel, and I have -12 equals 8x minus 9x is -1x, and then plus the 14. Okay, now I have my x right here, and I'm trying to get it by itself. So remember that we undo the multiply or divide second, and we undo the add or subtract first. So we're going to subtract the 14 over to the other side. Undo the add or subtract first. So this is gone. -12 and -14 is -26. And right now that equals -1x. Is this solved all the way? And you should tell me no, because the x is not all by itself. There's still a -1 in front of it. You wouldn't have to write that the 1 if you didn't want to. You could just put -x, but it is still there. And so we're still going to have to undo it. So I'm going to undo by dividing by -1. Dividing by -1. Technically, you could also multiply by -1 because the coefficient is 1. But I like doing the divide because it keeps me thinking in the same steps and the processes from before. I'm taking -1 times x. So I undo multiply by divide. So x equals -26 divided by -1 is a positive 26. And this is my answer. All right, the only other thing that I need to talk to you about is that sometimes problems like this that have variables on both sides of the equation end up having something interesting happen. We have something called our special solutions. Let's take a look at this example and let's see what happens. If I have 4 times 3d minus 1 equals 12d. I don't know when I look at this problem necessarily that it's going to have a special solution. That shows up as I start to work out the problem. So I start off my steps the same way. Get rid of the parentheses by multiplying by the number in front. Distribute that in. So we have 12d minus 4 equals 12d. Okay, well, this is interesting because if I'm going to move this 12d to the other side of the equal sign, moving it means I need to add it or subtract it. Since this is a positive 12d, I'm going to move it by subtracting it. But see, here I have a positive 12D minus 12D. They cancel. And I'm left with negative 4. But over here, I have a 12D minus 12D. And so they're also going to cancel. Does that mean that my answer is negative 4? Everyone tell me no. No, no, no. Because we still have this equal sign. But now what's happening is that on this side of the equal sign, there's nothing. Everything cancels, so it's empty. And so we have to put a 0. So now we have to ask ourselves, what's going on? Well, my special solutions, first of all, special solutions happen when the variable cancel out. So now there is no variable left. Okay. And the next thing that we have to do is decide is what is left. Is this true or is it false? Well, is negative 4 equal to 0? No, that is false. And so when we have a false statement, this is a no solution answer. Meaning there's nothing that we could plug into D, into the original equation, that would give me a true statement once I simplify it out. No number is going to work, so there's no solution. I'm thinking, if I'm remembering correctly, you guys have probably seen the no solution symbol, haven't you? Okay. The no solution symbol looks like this. And you can absolutely put that as answers on tests and quizzes. Okay, well, let's look at what would happen if we had a true statement happen. So let's get a different example. So if we have negative 2 times 4y plus 1 set equal to negative 8y minus 2. All right, I see parentheses over here. So how do I undo that? Distribute. Negative 2 times negative 4 is negative 8, and the y comes along. Negative 2 times 1 is negative 2. The right-hand side of the equation, we haven't done anything with it, so it doesn't change at all. Now, there's a couple different things that you could stop and think at. First of all, you could notice that at this line, both sides are exactly the same. So that's going to lend itself or tell me automatically that I'm at a true statement. But let's say you didn't notice that right away and you just started solving some things out. So, okay, I'm going to take this negative 8y and I need to move it to the other side of the equal sign. And so to move this piece over, I have to add it or subtract it. So I see a negative, and so I'm going to add it to the other side. So I'm undoing it, but I'm always only adding or subtracting. I'm never moving by multiplying or dividing. So that's going to cancel out. What I'm left with is negative 2 equals negative 2. Now, is negative 2 equal to negative 2? Yes, of course. So this is my true statement also. Again, notice how the variables canceled on both sides. I'm left with a true statement. So when this happens, instead of my answer being a no solution, we say that my answer is an all solutions. Sometimes you'll hear it read like that. Sometimes some books will say all real numbers. I'm okay with you telling me either of those two. It's all solutions or all real numbers. All right, so those are the examples that you guys need for your notes. We'll work on more word problems and some of the trickier ones in class together. I cannot wait to see you guys next. Have a great day. Bye.